Everybody, Alicia Panzarella here, taking a look at our newest engineering design challenge, which is actually re-engineering a Bristol bot. So that was our defined problem, and with our defined problem, we have to ask a couple questions, starting with, how does a Bristol bot even work? What are the pieces that make it up? And then how can we modify it? How can we redesign it? So basically, the Bristol bot is just a simple circuit. You have your battery, you have your motor, and then your switch is just the wire that you manually attach. So as far as a STEM lesson, there's really not much to this. This was a very quick procedure. It was a prescribed procedure. We put it together and then we did absolutely nothing with it. So at most, we're asking the question of how does a Bristol bot work or how does a simple circuit work? And because we're dealing with a circuit, we have a minor bit of technology, but that's really it. So let's make it better. So when I was brainstorming potential options of, what modifications do I want to do, I should note that being that I teach physics, I'm literally teaching the electrical components, the circuitry that goes into this. So I didn't want to just make a modification just, to do this activity for a Millersville class and then just move on. I wanted to do something where I could actually create a STEM lesson for my classroom. So I did originally think that I wanted to do something with a cat toy because my cats got a hold of it and they thought it was fun. But I didn't want to do that. Like I said, I wanted to do something that could be applicable in my classroom. So I thought to do something with an electric toothbrush, but that wouldn't work out because the frequency needed to replicate an electric toothbrush is about 200 hertz. And I calculated that our BristleBot currently works at 12.5 hertz. So if we would try to get to 200, we'd pretty much blow it up. So I came to application of uniform circular motion and electricity. How can I do something with this? But you may be wondering, why would you want to do something with uniform circular motion? So long story short, pretty much this is oscillating. When you have an oscillation, you have a sine function. When you have a sine function, you can create circular motion. That's kind of how the sine wave works. So when you put the Bristol bot down, the first time that I had put it down, I had noticed that it did kind of go in a straight line, but then it did start to curve after a while. Well, my modification was I simply moved around the bristle pieces, or I'm sorry, the pipe cleaner pieces, made one end longer than the other and got a very definitive circular path. And it was consistently a circular path. So the problem that I would give to my students with their little Bristol bot is how can you achieve a tangential velocity of 0.5 meters per second? Now, how is this an improvement? Well, it's an actual STEM challenge because there's plenty of student choice that would have to go into figuring this out when they're modifying their design, because we see here that they could figure out how to form different radii. Their period would be different, so they could actually change the design of the Bristol bot. Or they could actually change the circuitry. So they could add resistors, capacitors, another battery in order to achieve that tangential velocity. So there's a lot of change that could happen here and everything that would be student driven. So this now becomes an engineering design challenge. It has the mathematics in it that they would need. So this improvement is something that would actually create a STEM lesson.